today, the only thing we're going to pull out of lesson 10.2 are the stem and leaf plots. Okay, I want you right now to take your pencil and I want you to put a circle around what is a stem and leaf plot. And then I want you to read that to yourself. Stem and leaf plots are probably one of the trickier ones to read if you don't understand how they operate. It's going to be pretty hard to gain any information from them if you don't understand how they're put together. So it's really important in here also, I want you to put a box around this right here. A leaf is the last digit only of the data piece. Every leaf is representing the last digit only of a data piece. Trey?
How come clicking then it says 5 and then the leaves is 5 and 6?
Okay, so we'll talk about that in just a little bit here. So the leaf is the last digit of our data piece. The stem, okay, this is another important part. A stem, the digit or digits other than the last digit. So, if my age is 60, what's the last digit of my age?
0.
0. What is the other digit or digits of my age? 6, right? So 6 would be the stem part of my age. 0 would be the leaf part of my age. Okay? Let's talk about quiz scores. If you get a 100, that's your percentage on the quiz. What would be the leaf of your quiz
0.
score? Just the 0 at the end of the 100. What would the stem be? That would be 10, because those are the other digits. So you have this quiz score of 100. The 0 at the end becomes the leaf. The 10 in front of that last 0 becomes the stem. What if you have a quiz score of, 82?
2.
2 is the leaf,
And 8.
and 8 would be your stem, right? Okay. So that's how we decide what's going to make up the leaf and what's going to make up the stem. Okay, well here, let's look at what the problem is that we're working with here. The amount of money collected by each student for the drama club is shown below. The amount of money, so all those data values represent dollars. So one of the students collected how much money? $55. Another student, Riley, collected Cameron? $56. Another student collected, how much is that? Josh? Another student collected $66, okay? Another student collected how much? Isaac? Okay, we'll look at it right here. You know what, guys? You just need to look at that list of data right there. It says the amount of money collected by each student for the drama club is shown below. Use the data to make a stem and leaf plot. Those are all the dollar amounts collected by students. So first of all, would you tell me how many students are there that collected money for the drama club? How many are there?
16.
How'd you get that, Isaac? You got 16.
I just counted how many all of them together.
So you counted how many data values there were? So, you guys agree with them? There's 16 students in this drama club that collected some money? You're saying 17, Malcolm? Okay, so what are we going to go? It would be good to know how many there are. Okay. 16? Okay. You know what? Here's a pretty easy way to determine. No, here they are. Here's a pretty easy way to determine how many there are, and then how many there should have been where you got it from. You count how many leaves there are. Let's count in this table how many leaves there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is how you double check to make sure that you've included all of them. If there's 16 leaves, then there better been 16 data values. 2, 4, 6, 8, 9, 10, 12, 14, 16. Yeah, there's 16 students. Cam?
So the 7 just there, it's like a space filler, so there's not like a gap between 6 and 8.
Right, exactly. Trey?
Is it, so like, if it's 55 and it's also 56,
Okay,
Do we do that because there's 1 5, there's 150, and then there's a 5, and there's also a 6, so that's why there's 1 1.
so any of the amounts of dollars collected in the $50 range, those leaves go with the 5, that is the stem. So let's look at this. There's a 55, and there's a 56. Are there any others that collected a dollar amount in the 50s? Between $50 up to $59. No, there's just those two, right? And notice, so this 5 right here is representing remember the other digit? So the other digit of 55, the other digit of 56, and here are the last digits of those two. Okay? Well, then we move on to the $60, and by the way, once you decide where to start, you always start at this is why they said to you, the least value is 55. You always want to decide what's the smallest value in there, because then I can know where I can start with my stems. I don't need the 40s, I don't need the 30s, I don't need the 20s, why waste all that space? I can start with my stem being a 5, and the largest value is 116, so I can end with the stem of what? 11. So I'm going to go 5, 6, 7, 8, 9, 10, 11, and I'm not going to worry about if there's some for all those categories. I have to include them all. Once I decide what is the smallest and what is the largest, I start at that smallest and I include all of them along the way. Okay? So what happened then is when they get to the 6s, they look and see, are there any in the 60s? Well, here's a 68 and here's a 66. Are there any others? Are there any other dollar amounts in the 60s? No. And notice in the list it came as 68 and then 66, but look at the order they put them in here. What did they do? They put them in numerical order from least to greatest, and that's what we do. We want order in this stem and leaf plot. Okay, so least to greatest. Okay, and then why are there no leaves for 7?
There's no 7.
There's nobody that collected money in the $70 range. No one collected $70 or $72 or $75. Nobody collected in that range. So we still put the stem there. Notice the stem 7 is there, but we don't have any leaves for it, showing there were no data values in that particular stem to go with that 7. Okay, so notice, here's another thing that we got to notice. How come there are 2 zeros there?
90s.
Because there's 2 90s. Do we have to account for both of them? Yeah, we do. We account for both of them. If there were 6 students who had collected $90, how many zeros would we have for leaves? We'd have 6 zeros, okay? Now another thing, so this is what it says here. For each stem, write the 1 digit from least to greatest. There can be a repeat leaf. That's important. There can be a repeat leaf. So you have to represent every data value it's saying to you. But there's another thing I want to stop and I want you to notice is going on here. I want you to notice that, and I'll do it with this. What's true? They're lining them up nicely in columns, aren't they? Are there any commas in between these? No. So how do we keep them apart from each other then?
Make them straight up and down.
We put some space between our columns, right? You don't have to put lines, no, but keep some space between your columns. So make sure that you don't put the 5 right next to the 6th leaf because, you know, they're going to kind of be on top of each other. Give them a little bit of space, okay? Give them each their own territory. And then last but not least, what we have to do is we have to write a key explaining the values. In other words, when somebody looks at this, the first time you look at a stem and leaf plot, would you know how to read that?
No.
Me neither. I gotta understand what it's trying to tell me. So you pick anything from the table. You can pick anywhere you want out of that table. They picked that one. They show, so this is the one they picked right here. They just grab that out of the table and they said, when you look at the table and you have an 8 bar 2, that means 82. That tells you it's 82, not 8 bar 2. Okay? 8/2. Okay, then the other thing that we are going to look at is, well, what if we have to make a back-to-back stem and leaf plot? What if they give us 2 data sets? Like this one, the test scores from 2 different math classes are shown below. Class A and Class B. So what you're going to have to do is you have to pick the lowest value of either class, because you got to know where to start with your stems. Well, one class, the lowest score was what? Class A, what was its lowest score? That was a 50. What was the lowest score in Class B?
75.
No, 52. There it is, right? So they both ended up with scores in the 50s. So that's pretty clear. We're going to start with a 5 for a stem, aren't we? But once we start with a 5 for a stem, then we're going to decide how far to go. Well, we have to find the highest value so we know where to stop. Well, the highest value is 100. So that's a stem of what? 10. So then the highest stem we need to go to is 10. So notice what we're doing here. The stem's kind of taking the middle column of the table. So here's our stems. We only need a stem for one time because we're going to display the leaves back to back. We're going to go like this. We're going to say here, they're sharing this stem, but here's Class A's data, here's Class B's data. Okay? Other way around. Class A's data, Class B's data. Okay, and then here's a kind of an important thing to do with the key one on a back-to-back. You know what? Tell them how to read it both ways. So this is the one reading it from left to right. But this one is the one reading it, where am I at here? Right here. Well, don't worry about that one. This is the one that they're showing here. 5 bar 9 means 95. You gotta show them how to read it backwards too. Okay, because remember this is 90. That leaf is a ones place, it's a 5. It's not 59, it's 95. So we need to show the reader, you know what, here's how you read it forward, here's how you read it backwards. Okay? Okay, we're going to do a back-to-back one because those are the more challenging ones. We're going to do one together here. The daily low temperatures in degrees Fahrenheit in a town in the Northeast are given below. Use the data to make a back-to-back stem and leaf plot. Okay, let's look at, one of them is the daily low temperatures, the other one's the daily high. You always need titles on there. They've already been put there for you. On the left, we're going to display the low temperatures. On the right, we're going to display the high temperatures. We got to decide where we should start with our stems. So what's the lowest low temperature? Cam? 40?
36.
Oh, 36, like right here? Is this it, right here? Is this the lowest low temperature? Okay. What's the lowest high temperature?
62.
I can't even find 62.
It's like to the top.
Top row, 62.
Well, the highest.
Oh, yeah.
I want the lowest high temperature, Josh.
Oh.
58?
66.
58? Okay, because we gotta make sure we have the lowest of both of them. So what's the lowest of both of them now? What's the lowest of both of them? Is 36 or 58 lower? 36. So we're gonna have to start our stems at 3. Okay, what's the highest low temperature?
7. 8.
Highest low temperature.
63.
63 right here. What's the highest high temperature?
84.
84. Okay, so how far do we have to take our stems? Up to 6 or up to 8?
8.
We got to take it all the way to 8, don't we? Okay, so we're going to do 4, 5, 6, 7, 8. So our first decision has to be, what are the stems? We find the lowest of all the data, we find the highest of all the data, and we decide from that where our stems are going to start and where our stems are going to end. Okay, now it's best to do one of them at a time, okay? Here's the thing that sometimes makes it helpful. When you're looking, if there's more than one of them in that stem range, you're going to have more than one leaf. Sometimes it's a good idea to just write them down somewhere so you can make sure you put them in the right order. Okay, because we're going to go backwards here. So how many 30s are there in the daily lows? 2. We got 36 and we got 39. So we got 36, 39. So 36, which one would come first, 6 or 9? When you're going from smallest to largest, 6. So we'll do 6, give some space, a 9. We're making our leaves. Once we've done that, we can cross them out of the table so we don't, try and use them again. Double check, make sure there are no more 30s. Are there? Okay, how about in the 40s? Do you have any 40s? How many? Well, let's just start writing them down. We got a 40, we got a 49 in the next row, we got a 48, we got another 49, we got a 40 again, we got a 42, and a 44. Did we get them all? Okay. Of those 7, we should have 7 leaves, shouldn't we? Okay, what's going to be our first leaf?
40.
So that would be a leaf of what?
0.
0. Now notice, you don't have to worry about that there's a 6 above it. We don't care about that.
0.
And then there's another 40, so we have to have another 0.
2.
And then the next smallest would be a 2, okay.
8.
And then we have a, I don't know, I think I got a 4 here.
Or 4.
I'm thinking that 4 would come next.
And then 8.
I'm kind of writing kind of big. I hope you're doing better than I am. I'm gonna run out of space here. I gotta scale down here. Two, 4.
8.
Next one would be 8.
9.
Only one 8.
And then 9.
A 9.
And 9.
And another 9. Okay. So 1, 2, 3, 4, 5, 6, 7 data values. I should have 7 leaves then. 1, 2, 3, 4, 5, 6. I got 7 leaves. I'm feeling good.
Does it have to be in order?
Yes, it needs to be in numerical order from least to greatest, those leaves. And then once you've done that, then it's a good idea to go to your table and just cross all those guys out. So that 40 got used up, that 49 did, that 48 did, that 49, that 40, that 42, that 44. You know what? Get them out of there. Okay. Do we have any in the 50s?
No. Yeah. 0.
Yeah, we got a few of them in the 50s. Here we got a 56, we got a 50, we've got a 59, we got a 57, 52, and a 53. Okay, what leaf is coming first? 0. What leaf is next?
2.
2. Remember, nice columns, nice vertical columns. What leaf is next?
3,
3. Next?
6,
6. Next?
7,
7. And
9.
9. We have 1, 2, 3, 4, 5, 6 leaves. We had 6 data values in the 50s. Liking that. So now I'm going to cross my 50s out of there. See, this is part of my stem and leaf table, that 9 right there. Don't. You got it too, right? Do we have any in the 60s?
Yes.
How many?
3.
3 of them, okay. So we have a 60, a 62, and a 63. Oh, yeah, that one that was the high, wasn't it, or the low? Okay, so we have a leaf of class
0.
0, another leaf,
2,
next leaf
3,
3. Okay, how many temperatures were in that table?
3,
It's a 1, 2, 3, 4, 5, 6 by 3. How many were in there?
18.
18. Do we have 18 leaves? We double check before we move on. Count. Go ahead, on your papers, count. We have 18 leaves. I do. Do you? Do we care that we don't have any in the 70s or 80s? No, we don't have to have any. Okay, you go ahead now and you do the highs. Go ahead. Finish your stem and leaf plot. Get the highs. Oh, I've already seen some of us aren't doing good columns. Nice columns. Don't get half points taken away because I can't line up a ruler between your columns. Again, that table is a 6x3, 6 times 3, 18. We should have 18 leads when we're done. If you have questions, get your hands up. If you're done, see if you can make a key. Remember, you need a key that tells them how to read it forward and backward. A stem and leaf plot cannot be left without a key. I'm going to be mean to the reader. Okay, somebody give me an example of their key when this person is reading it backward. Shamarki?
6 is 0.
So 6 line 0.
Yeah.
Okay. Means
Reading it backwards.
means what? What value? What's it mean?
60.
60. So he's talking about this one right here, folks. Okay, I'm just going to circle it in there. Right? Is that the one you meant, Shamarki?
Yeah.
Okay. So reading it backwards, Shamarki is showing them how to read it backwards. But something's wrong with that. That's not how it's in the table. Josh? It's 0, 6. We have to show it the way it is in the table, because otherwise they're going to be like, I don't see that. So we have to have the 0 here and the 6 there. So instead of reading that as 0, 6, that doesn't really mean 0, 6. It means 60, doesn't it? Yeah. So we have to show them that. We need to, let's be helpful. Okay, well then, so key. Guess I should have my colon there. Somebody give me an example that would help them read it forward in the table, in our stem and leaf plot. Okay? Trey.
8 line
8 what?
4. 8
4?
line 4.
Okay. And that means
84.
84. So this one right here, right, Trey? Is that the one you were taking? Okay. Now you don't need to circle them in your stem and leaf plot. We're just doing that to verify where did it come from, so you know how to set up your own key. Okay, now I want us to do some interpreting from this stem and leaf plot. We're not done. You don't have to write this down, but you're going to be with me. Okay? I want you to tell me what was the lowest low temperature.
36.
Everybody want to agree with Shamarki? The lowest low was 36. Okay? What was the most common low temperature? What was the most common low temperature? Josh? 40 degrees. In fact, it's the only one that showed up more than once, isn't it?
Yeah.
Most common means shows up most, right? Okay.
Wait, 9 should have come in once. 49.
Oh, so the most common would be 40 and 49. Okay, so the most common daily low was 40 degrees and 49 degrees. Okay. Tell me, was the daily low temperature ever 70 degrees
No.
or above?
No.
No.
What was the highest low?
60.
63.
63, because it's when we're reading the table, it's the last leaf, the lowest one on the table, right?
Yeah.
Okay. Tell me, what was the most common high temperature?
70 degrees.
70 degrees. Okay, how many times was it 70 degrees?
4.
4 times. Now, should we have to look at our back of our table to see that?
No.
No, we should be able very clearly now to see it. Anybody know what that's called? The most frequent? The one I just asked for, I asked for the most frequent
Most consistent.
high temperature. There's a mathematical term for that.
Consistent.
The one that shows up the most. What is it, Cameron? It's the mode. And we're going to be doing, that's coming up too. We're going to be doing mode. Anybody remember any other things about
Range.
mean and range and, what was that one you said, Malcolm? Mold?
Maximum, minimum.
Minimum, maximum, yeah, all those things we know that. Tell me, what is the range of low temperatures?
The first number.
What's the range of low temperatures in this, from this stem and leaf plot? What's the range? Josh? 36 to 63. Oh, well, kind of like the number and then it just turned around backwards. So 36 to 63. Well, if we wanted to say what the range of low temperatures is, what was the actual temperature variance, how much would that be? Well, we'd have to turn it around and make it into a subtraction problem, and what would that be?
32. 30? No.
Darling, you can get the math in your head.
27.
27. So there was a range of 27-degree temperature variance on the daily lows. Okay. What was the range of the high temperatures? Trey?
65 to 84.
65 to 84. Really?
Oh,
58 to 84. Which then we'd have to turn it around into a subtraction problem. And what was the variance in the high temperatures?
34.
36.
26.
Oh,
So, pretty close, wasn't it? The range of, are we right? 58 plus 6 is 64, 20 more is 84, are we right about that? Okay, so anybody have questions about how to make a stem and leaf plot? Am I gonna consider it done without a key?
No.
No, absolutely not. Okay, if we have stems that don't have leaves, what do we do about that? Leave them there, let them be, let them sit there by themselves. If they don't have leaves, we know that there were no values in that particular, that go with that particular stem.